All right, so what we're going to do is that we're going to find each of the following. Same thing like example number 5, and then we're going to find their domain. All right, so f of g of x. All right, so that means we're going to find f of g of x, which then means actually we can replace g of x with 4x. All right, and now what we're going to do is that we're going to replace both of these x values with 4x. So I did for the first one. Now I can replace that with that guy right there. So f of 4x is actually negative 4x cubed plus 2. All right. Negative stays right there. 4 cubed is 64. X cubed is x cubed plus 2. And there's nothing else we can do to simplify that. Now, to find this domain, again, we ask ourselves, are there any restrictions to this? Is there any number that we cannot plug in? Well, no, we can plug in every negative number, every positive number, and even 0. So the domain is going to be negative infinity to infinity. Okay. All right, coming over here, we're going to do the same thing here. We're going to do g of f of x. I can replace f of x with negative x cubed plus 2. So g of negative x cubed plus 2. Okay, so I replace f of x with negative x cubed plus 2. Now I replace this x now because now I'm doing g of x. So g of negative x cubed plus 2. I'm going to replace this x with this guy. So move this over here. We're going to get 4 times negative x cubed plus 2. Doing the distributive property, we get negative 4x cubed plus 8. It's very similar over here. Is there anything that we can, is there any number that we cannot plug in? The answer is no. I mean, we can plug in every number. So the domain, once again, is from negative infinity to infinity. So just so that, because I keep saying like if there are restrictions. So say if you had something like this, like say if your final answer was like 1 over the square root of 3 minus x. And then I said, okay, what's the domain of that? Now here, it's not going to be all real numbers because there are restrictions to this. Okay, well, first of all, the denominator can't be 0. Okay, that's first of all. But then secondly, this is a radical, right? There are certain numbers that cannot be in the radicand. Radicand is the whatever values are underneath or inside the radical. So basically what you want to do is see, okay, when is 3 minus x? When is 3 minus x going to be greater than 0? Okay, not equal to 0, because if this is equal to 0, then the denominator would be restricted even again. So if I find what this is, negative x is greater than negative 3, and then I divide both sides by negative 1, I get x. I flip the inequality, is negative 1 right here. So check this out. That means my x values down here has to be less than negative 1. It has to be. And if it's not, or if I pick numbers that are, say for example, like, see, this x is less than negative 1. So pick a number that's not less than negative 1, like 0. Well, if I put 0 right here, 1 divided by, oh no, okay, that's going to be okay right there. Hold on here. So it's negative 3 less than. So we're trying to look for when these are going to be positive right here. So let's see here. Then that means then, so a number that's less than negative 1. So say if we had like negative 2 or negative 3, negative 4, negative 5. If you plug these in right here, those are all going to be fine, right? I mean, if I plug in negative 2 right here, 3 minus negative 2, this is 3 plus 2. But what happens here is what happens if you plug in, like, for example, like 3. Or if you plug in 4, or 5, or 6, or 7. If you do stuff like that. Because if you plug in 3, now the denominator is going to be 0 right there. So you can't plug in 3. Okay, what happened right here? I'm sorry about that. Oh, you know what? Okay, negative 3 divided by negative 1 is a positive 3. Sorry, man. Trying going crazy right here. I'm like, what the heck's going on? All right, it's a positive 3. Okay, so that's why. So all numbers have to be less than 3. Okay, so that means if you plug in 3, 4, 5, 6, 7, that's where the restriction is. So now if you want to talk about what the domain is, okay, well, the domain is going to be all real numbers that start at 3. Well, actually, that's going to be the biggest number. So it's going to go from negative infinity to 3, because it says all real numbers that are less than 3, meaning the biggest number is 3. And the smallest number that's going to go to, well, you can do all numbers that are going to be negative infinity. So this is what that domain would be right here.